Hi, my name is Mikkel, and in this example we are going to look at how the pile geometry affects both the installation parameter measurements and the bearing capacity. We are again in the sand pit at Aalborg University, where we can control the soil profile very precisely. In this example we set the soil profile, advancement ratio and speed to the same values for all 4 piles. So we make those constants, and the only thing that's variable now is the pile geometry. In some literature, piles 1 and 2, which we call screw piles, are also referred to as continuous helix piles, where piles 3 and 4 are called single helical piles. Pile 1 has a diameter of 76 mm and a T12 thread. It was perfectly installed at 10 RPM and it measured around 2,600 Nm during the last rotation. Pile number 2 has a diameter of 89 mm and a T12 thread. It was also perfectly installed at 10 RPM. It measured a torque of around 3,800 Nm during the last rotation. Pile 3 is a single helix pile. We distinguish a helix pile by its large disc compared to the other screw piles, who has continuous threads. It has a diameter of 76 mm and the helical disc is 276 mm in diameter. It was installed perfectly and at the same speed as the other ones, and it measured a torque of around 3,600 Nm during the last rotation. If you look at pile 4, it's the same single helix pile type as pile 3, although it has a larger diameter of 89 mm. So the helix's diameter is 289 mm. It was perfectly installed at the same speed, and it measured around 4,200 Nm during the last rotation. When you look at those torque measurements, you would expect that pile 1 has the lowest bearing capacity, then it's pile 3, then pile 2, and lastly pile 4. If we go by the general theory that torque is equal to bearing capacity. Unfortunately, that isn't true. If we look at the bearing capacity of a static test, you can see that pile 1 had a bearing capacity of 50 kN, while pile 2 had a bearing capacity of 72 kN. Pile 3 110 kN, and pile 4 127 kN. In particular, piles 2 and 3 show inconsistencies between torque measurements and bearing capacity. Although pile 2 had a higher torque during installation, it had a much lower bearing capacity than pile 3. So, just saying that a certain torque gives a certain bearing capacity has been proven by Aalborg University's research to be invalid, because the type of pile a project uses strongly influences torque measurements and bearing capacity. And in the rotation speed example, we saw that rotation speed would affect the torque measurements, but not the bearing capacity. This further proves that you cannot simply say a torque measurement is equal to a bearing capacity without ensuring that your installation energy is the same for all the piles and correlating the bearing capacity to a torque measurement through a load test. I hope you found this information useful and that it provided insights into the importance of correctly monitoring and documenting a screw pile project. Follow for more information, where we will look into other examples and important areas when using screw piles in your project.